right, it's 2 o'clock, and I think we've got most people here. So, um, got a few assignments, and they look really good from the ones I've received. And there are a couple questions that I'm going to look at today. One has to do with how to attach things like the slope values or the aspect values to the final solution polygons. So I'll show you how to do that. And then there was a question about working in the print composer, and so I can show you some things there. But let's go around and see if there's anything else that anyone wants to discuss or ask about. We'll start with you, Laura. Is there anything that you would like to, you're wondering about or would like to see?
I was just doing the assignment and I just popped into a problem as this meeting started. But I think I will. Yeah, it's when I try to clip the final layer result and the suitable soils, the two vector layers. I get 1 second. I get a box where it says no spatial index exits for
That's
input
okay.
layer. Okay.
That's okay.
But I also think that if I just work a little bit around with it, I will know how to figure it out.
Yeah, that's not a real problem. It's kind of just information for you. So if you don't have a spatial index, QGIS will always tell you that. If you want to build a spatial index, you can go into the layer properties for that vector layer and go to the source tab. And there's this button to create the spatial index.
Okay.
Click that and it'll be there. But none of the data that we're working with are big enough that it's going to probably cause any performance benefit to build that. So it's just QGIS giving you some information. But hopefully the clip works okay.
Yeah, in Danish we have two functions in QGIS, which seems like the picture of them is the same.
Okay.
And it's called, I'll just find it. One of them is clip, and then another one is scaring, which is like where they cut, I think.
I think that must be clip and intersect in English.
Yeah, maybe.
Let me look. I have a Danish profile I can look at here. Yeah, you want the clip? That should be the one. Then I think, yeah, scaling is going to be what we call an intersection. So if you had, what's a good example? Let's say you have forest polygons, and then you have communa, and you want to figure out how many hectares of forest there are in every communa. So you need to have those forest polygons cut at the communa boundary. So you would use scaling for that, and it would cut one layer based on the geometry of the other. So it would produce more, it would create more forest polygons wherever it crosses a municipal boundary at that point. So, but clip is the one that you're going to want to use here.
Okay, great. I think I'll figure it out.
Okay.
I hope so.
Yeah. How about you, Jakob? Anything come up for you that you're wondering about?
Nope, no, not yet.
Okay. And let's see. So, Jonathan, you wanted to talk about if once you have your solution here, how would you go about adding additional attributes to those polygons for some of the raster layers that you had, like slope or aspect or what have you. And so
yeah, because I was thinking, like, because I put a label with the hectares, and I was thinking, it would be nice to say like the mean slope or some other things that we actually calculated to present that in the end. If how do I bring it into some kind of vector layer or gather that up in one place.
yeah, okay, so I can show you that. So so yeah, I've got my here's my slope layer here. So if I wanted to have let's say the mean slope of each potential vineyard polygon, it would be the same process I showed you for putting the raw result into the parcels vector layer. So I'd go into the processing toolbox, move this zoom window out of the way, and going to search for zonal statistics and find this zonal statistics algorithm. And so the input layer is going to be my final vineyards. And then the raster layer will be slope in this case. I can give it an output column prefix, so I could call this this slope for the prefix for each column that it adds. And then if I check this box here, statistics to calculate, I can choose what I want it to compute and add. So here it would add 3 new columns, one for the count, which would be the number of pixels, the sum, which would be the sum of those values, and then the mean, which would be the average slope. So I think here I'll just use the mean, but you can choose as many of these as you need. And then save this out to a layer. I'm just going to use temporary output for this. Click run. And so it produces this zonal statistics layer. Since I didn't give it a name, it names it after the algorithm that I ran. So it's the same geometry as my final solution. And if I use the identify tool and click on one of these, I now have the slope mean attached to that. So that as you were suggesting, I could label this layer with that slope mean. And it's going to have, well, it's kind of hard to read here on the aerial photograph, and it has a lot of decimal places. So let me just put this label onto a background. Or no, I don't. That's wrong. I'm going to put it on a background like a rectangle so we can see those values. And so they have a lot of precision, a lot of decimal places. So I can go in here and use a labeling expression. So there's a function called round. Yeah, there it is. So I can use round on slope mean to just give it fewer decimal places, like maybe 2 decimal places instead of the 8 or 10 that it has. So now it'll be a number like that. And so now I have them labeled with the mean slope for each one. And you know, then we could get into labeling options like using call outs or something like that to make it look nicer. So if anyone wants to see labeling, let me know. But we have them labeled with that new, so we could repeat that and add as many zonal statistics operations as we want. We could run it again and add aspect, etc. So zonal statistics is what you're going to use for that.
Yeah, thanks. Yeah, you actually showed that last time very shortly, but okay, so that's the function. How is there a way to bring, because it's the same geometry, like if I would like to bring the same into the same, like master vector file, like so it would be an attribute in, so I don't have the same geometry duplicated, or how to speak, because now you created a new vector layer. Like, can I combine like the attributes somehow, or is that possible?
Yeah. So we could do a join. So you could join this at the zonal statistics attribute table to this based on the feature ID. So if I open up the attribute table, oh, we don't have feature ID in here, but we can add it. Let me see if it would come out the same. But here's another, just a useful QGIS thing. If I want to add a field that has the unique ID here, had I saved it into a geo package format, it would have automatically had a feature ID. But since I think I saved this as a shape file, it doesn't automatically have a feature ID. But I can add a new field called FID, and then I can calculate that to $ID. The $ID is the ID for each feature in a layer. And I can just choose update all. So now I have 0 through 17 here. And I think if I had that created that same ID in the other layer, I could then just join based on that ID. I think they would, the two layers would have the same order, but I'm not positive. Let's see, we might be in a situation where just because I chose shapefile, I made it a little difficult here. So let's see, I'm gonna add another FID to this layer, do the same operation, $ID, update all. And let's see if I just label this one with feature ID. And then label this one also instead of that with feature ID. Yeah, it looks like, yeah, they're keeping the same IDs. So you could do a join between those two layers to join the values to this. So in other words, now I could go into the layer properties for final vineyards, go to the joins tab, add a join, and tell it I want to join the zonal statistics. I'm going to use FID as the join field between these two. And click OK. OK. And I should now have that joined to my, final vineyards here. Don't know why that one didn't come across. Feature ID 0.
But yeah, nice. But yeah, you have to have some kind of common thing to join them together.
Yeah, because unfortunately the zonal statistics creates a new layer each time you run it. But there is another zonal statistics tool that'll output a table, and we might be able to, that's zonal histogram. Yeah, it's going to create another version of the geometry though. So I don't think there's any getting away from that if you want this. But it could be, again, I think we discussed this. This is something that you could assemble as a workflow that you build in the graphical modeler. And so you could just build all those steps of computing zonal statistics at the end in a graphical modeler, and you could have like this be you know, it's temporary output. So if you just had that as a temporary output in the model that wasn't going to get saved to disk, you would at the end just have one version of the geometry with everything appended to it, if that makes sense.
Yeah, thank you.
So there was one question about, I asked you to make a map, and I didn't really cover the print composer at all. And so there was a question about how to add, I think the data source and kind of metadata to a print composition. And Christian, you figured it out because I saw it on your assignment, so that's good. But if I want to create a print layout, I can go to the project menu, choose new print layout, give it a name, and you are basically given a sheet of paper, and you can use these tools on the left-hand side to add different map elements to your print composition. So this one, like the most important one, is the actual map. So you can use this to drag a box where you want the map to appear on the sheet of paper. And it depends on how you want to lay this map out. You could leave space at the top for a title, or you could just put the title over the map. Depends on your particular aesthetic. But the title would just be this add label tool with the T on it. And again, everything you add to the print composition is going to be a graphic object that you can resize. And the properties for everything that you add are going to be configurable in this item properties tab. So now I can type potential vineyards as my map title and change the font to something a little bigger. Maybe make it bold. And you have these tabs here for configuring the way that title looks. And then back in item properties, you can also align and center. And then if you wanted to add, what the specific question was, how to add the data sources, you can use that same text tool and drag a box where that's going to go. Keep moving this zoom window out of the way. And so you can position this in some place that's convenient on the map. And then, maybe you know, cartography, maybe for some of the other elements like the date in here, there's dynamic text available. So you can choose to add the current date. There's 3 default formats, and you can set that up. You can modify that if there isn't one you like here. But so we could choose 11/5/23 as the date. And then you can see what that has done is added an expression to your text box using the now function, which returns the current date and time. And the now function is wrapped in this format date function, which has these tags for how to format the date. So, if you didn't want backslashes, you could use dashes in here. You can use any kind of notation or date formatting in here that you want. And the format date function will also give you the syntax for what to include, with DD being the day with the leading 0, MM being the numeric month with the leading 0, and YYYY being the year. And then you could add a line for data sources, and type in data for Suning, etc. So that that's down there, and then you can change the font for that to whatever you're happy with. And then the other things that you can incorporate into a map is like the legend here. You can pop the legend on, and you know, one thing QGIS does when you first add a legend, like I have a bunch of layers in my project and it adds them all. So the legend needs the most configuration of anything in your print composition. So you can uncheck auto update, and then you can remove anything in here that you do not want on your map and click remove. So I just have my final vineyards in the study area perhaps, and I can select everything else and remove it. So I have a simple legend there. And since I had right-clicked on final vineyards and chose show feature count, that shows up in here too, which is nice. And then you can go in here and take the underscores out and make it nicer to read. And you can change the fonts. There's a lot you can do with the legend. If anyone has any specific questions, I'm happy to.
Did you
show you
get
some
the
tricks.
feature count?
That was back on the main QGIS canvas. So here in the main QGIS window, you can right click on a layer, and in the context menu, you'll have this option, show feature count. So it'll count the number of features and put it in brackets after the layer name. So that can be toggled off and on. And if you have a layer like this parcels layer, that's classified, it will tell you the number of parcels in each class or the number of soil type polygons in each class here. So that's so when you do that, it automatically, whoops, map. It automatically adds that to the legend. If I went back into QGIS and I unchecked show feature count, this would disappear off my map legend as well. It's just there because I had chosen that option. There's a lot of things you can do in QGIS, like custom legend patch shapes and things like that. And then there's, of course, settings like maybe you don't want the, this could just be floating on the map, so I could turn off the background for my legend and just have it sitting here. And then a scale bar is another useful thing, so people know approximate distances. So you could put in a scale bar here and choose a different one of the many styles for the scale bar, and choose the number and length of each segment. So here it's in meters, and we could put it into kilometers, or actually meters is pretty appropriate for this. And you can change the font size under display. That's where font is. So you could maybe reduce the size of the font a little bit on the scale bar. You can change the colors of it. All that is configurable in that item properties for the scale bar. And then Jonathan even actually had a locator map for this. So we could also add a locator map to this by, we want to create things called map themes. So a map theme is basically a definition of which layers belong to a map. So I could click here and add a theme and say this is the main map. And then I could also just select all of these layers and group them by right-clicking on all the selected layers and just call this my main map group. And then I could add another base map here. So maybe, I don't know, add the ortho photo from data for Suning. Where did it put that? It must have put it in here.
Yeah, it was at the bottom, I think.
Oh, it was. Okay. I have to collapse. Oh, there it is. Yeah. So I'm going to right click on this and move out of group. So now I have this as my a separate layer out of my main map group. So I can turn off the main map and turn on the air photo, and I can then call this my locator map theme. So now I have two map themes, and I can go back to this map themes menu and toggle between them. Let me recreate this one. Replace theme main map. Yes. You can always, if they end up making a change like that and it affects the map theme, you can also just recreate it again. So here's my locator map theme and my main map theme. So I have both, and I can bring up my print composition. And the trick is selecting this first map and telling QGIS that in this layer section that this map follows a map theme, the main map. So this is locked now with this set of layers. And so then I can add a second map here. And I'm going to tell QGIS that this follows the locator map theme. And I'm going to zoom out. This to all of North Shetland, so we can get a little context. So we have this locator map now, and I can go into the properties for this, and I'm going to add an overview. So I'm going to click the plus button to add an overview, and this overview is going to be an overview of map 1. And so now you see this red rectangle appear in this map where this map 1 is situated. And you can go in and change the symbology for this to maybe just an outline, a red outline. Like that. So now you have a locator map here so people can see where the study area is located. So that's another nice little touch that you can do. So that's probably a lot of stuff that I expect some of you already knew, but if you have any other questions about that, I'm happy to show you. And Kristen is not here, but I do have something that I prepared, so I'm going to show you. We were getting into lots of discussions about multi-band imagery, and this isn't obviously part of our course, but I have this series of Landsat images, and so each one of these, this covers part of Rome, Rome, Italy, and there are, this is band 2, band 3, band 4, band 5, band 6, band 7 of a Landsat 8 satellite image. So I have 6 different bands, and so they just cover the exact same area. They're just different bands of the same Landsat scene. So I can merge all of these into one raster that's a multi-band raster by using the merge raster tool. So if I go to the raster menu to miscellaneous, I can choose merge, and I'm going to select all my input layers. Well, not the OpenStreetMap base map, but all of my satellite images there. And then I'm going to tell QGIS to place each input file into a separate band. And I'm going to use the same data type that each of these have, which is unsigned integer 16-bit. And I'll just click run and save this as a temporary raster. So now I have all of these merged together.
How can they be integers? Are they float values?
Yeah, when I clicked on this, it's these are all unsigned integer 16-bit, the source. So this is just some sample data that I happen to have. So I think if you depending on how you acquired this from Landsat, you would have floating point, but this one happens to be integer.
But the band one says is 29.92 from 5. Isn't that the values in?
No, that's a 1,000 separator.
Okay. All right. Yeah. I get it.
So here's my merged, and it's a multi-band image. So these bands are, if we go to like the Landsat documentation, we have 2, 3, 4, 5, 6, and 7. So 2, 3, and 4 are blue, green, and red, the visible part of the spectrum. And we have a near infrared band and 2 shortwave infrared bands here. So you can look up different band combinations and change them here. So I could choose 3, 2, 1, and that's going to be like a true color band combination for this area. And then there's a false color urban band combination, and that's going to be 6, 5, 3. And so that highlights urban areas using some of the infrared and shortwave infrared channels. There's let's see, 4, 3, 2 is another false color image, but this one's highlighting vegetation. So all the vegetation is the brightest here in bright red. And then there's another one that highlights agricultural areas. It's 5, 4, 2. So now all the agricultural areas are highlighted in green, and the city is purple. So this is just an example of how you can, one, combine multiple bands into one, and then look at the different band combinations to see different things about the landscape based on how those are being piped through the red, green, and blue guns of your computer's display. And then, of course, if you wanted to go the other way and you wanted to go from this multi-band raster out to back to the single bands, go the other direction, you could just use the raster calculator. Because if I open up the raster calculator here, you'll see that each one of those bands is listed as a separate raster. So I could basically just specify band 7, for example, and save that out as a new raster. And then I would have that band 7 isolated. And so I also looked up, there was a question about how many bands can a GeoTIFF store, and it can store a lot. They can store upwards of something like, it's like as much as a 16-bit image can store values. So you can store thousands of bands in a geotiff if you wanted to. But so there's really no limit to that, essentially. So if you ever need to store multiple bands in a geotiff, it's completely possible with all of our modern satellite sensors to do that. So, sad she's not here because she had a question about that, but maybe she can watch the recording. So we still have some time if you want to show me anything on your side, or if you have other questions about anything that we've covered or things that we haven't covered.
Well, I think the model builder is quite cool. If there's no other questions more related to this assignment, maybe you can show how to do maybe a few of the steps in this assignment with the model builder.
Okay, yeah, that's a good idea.
Hmm?
Yeah, because I also, with the model builder, can you do the selections? I haven't looked too carefully, but the selection, because we use the manual, like select with an expression, and we use those in the model builder.
Yeah, there is a select by expression algorithm in there that you can use. So basically the model builder has pretty much all the tools in the processing toolbox, plus some special model only tools. So if you search for select in here, you can see you can extract by attribute or extract by expression, which will essentially do exactly what we were doing. Select by expression, select by attribute. So it'll just be a matter of importing that expression in there, and you could you could expose as much or as little as you want to in a model. So you can expose any input to a processing tool that you're using in the model builder as something that someone can fill in when they're running the tool. So let's just start. So if I go to the graphical modeler, I'm just gonna, if we don't have a ton of time, I'm gonna start with kind of some of the easier things here. So I'm gonna go into inputs, and I'm going to add a raster layer, and I'm gonna call this DSM for digital surface model, and I'll click mandatory and click OK. So I have that, and then I'm going to choose the let me see, is align rasters in here? I actually haven't built this whole thing in here, so I'm going to see what this is. Huh. It would be interesting if the line raster is not in here. That would be unfortunate. I don't see it. So let's just looks like a line raster might be difficult, unless maybe there's a workaround. I'd have to check. But let's look for slope anyway. And so we can search for slope and find that algorithm. And we can tell QGIS that the input is going to be the DSM layer. And so here in the processing modeler, if we leave this blank, this will be a temporary output. If we enter a name here, then this would be a place where the user could enter a name and save this out to disk. So it's entirely up to you what you decide to have as file-based outputs of your model. You can have everything get saved to disk, or you can have all the intermediate steps just be that, and just end up with the final result at the end. So I'm going to leave this as blank for now, and I'll click OK. And so we now have our slope, and then I can do the same with aspect. And this is also going to be using the DSM as input.
Kurt, is the DSM, is that just, it didn't seem like you connected it to an actual layer. Is it just a name for a layer or a placeholder, or how
It's a
does it work?
placeholder. Yeah.
Yeah, okay.
So let me show you how this will work. So if I, when you first start, you need to give the model a name. So I'll call this vineyard, and in the group, I'll just call this course demo. And I'm going to save my model. So now we have a saved model, and if I can close this, and if I go into Processing Toolbox, I'll see models as a new category in my Processing Toolbox, and I see Course Demo as the category, and I see my vineyard model. And if I run this, I have to choose the terrain aligned as my DSM. And then I just click run. So this is where I connect it to the data set. So yeah, the raster layer object in the model builder is just a placeholder. So when you're creating this kind of model, you're basically creating your own custom tool that's going to do whatever you ask. And so you can choose your inputs. And this is why you could run it in multiple locations, because we could have another study area in Denmark, and we could run this using a different digital surface model for that area and have it do the same thing. So I can go ahead and click run, and it will load. Let's see. Oh, I think, yeah, it didn't load those because I did not save them as permanent output. Let's make sure I'm right about that. So if I want to get back into this, I right click on my model and choose edit model. And so I could choose to go in here and save this out as an aspect data set. And then it would have this output here. And so now if I save this, I can also click run from here, from inside the modeler, and it'll just open this up as a tool. And I can choose my terrain aligned as my input, and I can keep this as a temporary file still, but it's going to add it to my map after I run it. So I can click run, and here it's added aspect to my model. So you can see how that works. So we might want to go in here and give this the name slope, so they both are actually added to our map after we run them. And then the next step would be using the raster calculator. And so you can see raster calculator is an algorithm in here. And we could, oh, actually we have to, that's not the next step. The next step is reclassification. So reclassify. Reclassify by table. So we could add this in here, and the input is going to be, instead of model input, it's going to be algorithm output. So it's going to be algorithm output from either the aspect or the slope. So we can choose let's do slope here. So the input is going to be the output from the slope algorithm, and then we have to create our table just like we did before. I think we had 7 rows. We go from 0 to 1, and that was 1, 1 to 3, and that was 2, I think. 3 to 6, 6 to 15, 15 to 20, 20, 25, and then 25 to 60, that's 1. And click OK on the classification table. And then we could call this my same naming convention, slope RC, and click OK. And so now we have the next algorithm in here. So now if we save it and click run, we're adding to our tool where it's going to create aspect slope and then the reclassified slope. We can click run and it'll run through all of those different algorithms. And so for this, you know, this is quite a few steps that you go through, and you would just keep building on it. And another nice thing with the model builder is there's this option here, this little green button, to save the model in the project. So this basically embeds this model in the project. And this is kind of a nice little feature because you can also save a QGIS project, let's say in a geo package. And so you could give someone a geo package that contained the data and the QGIS project file and the model being embedded in it. It would all just be in the same container. So for example, I could choose to save this model into the project. And now if I go to project, there's this models option here. And so we can see we have this vineyard model, and I can choose execute, and it opens it up, and I can fill in the parameters for this vineyard tool that I've created and run it. And another nice feature of this is if I go back in and edit this again. Oh, I saw it right there, actually. Right there. If I right click on this, you can see export model as a Python algorithm. So you could export this out and it will show you what the model would look like as a PyQGIS script. So if you're curious about how to start working with PyQGIS, the model builder is a great way to jumpstart that process because it's going to write all of the equivalent PyQGIS out for you automatically. And then you can just run this from here. And you could save this out to a script. And now you have scripts in your toolbox, and you have this same processing algorithm as a script tool in your processing toolbox.
Regarding scripts and models, is there like a community who shares different scripts and workflows? Just like I know that, I mean, there's plugins and there's styles and shapes you can download, but is there like models being shared around or a forum or something like that?
Yeah, there are actually. So there's a plugin called the resource sharing plugin. QGIS resource sharing. So if you install this, it will add this little green button to your GUI. And if you open this up, some of this is styles, icons, and things. but there are also processing scripts and models in here. Here's collection contains a set of resources for PISM parallel ice sheet models. So there's just anything in here that QGIS users wanted to upload and take the time to put there. So it's all kinds of things. So I would say the majority of this is icons and things, but there are also several processing scripts and things in here as well. And so you can look at all collections or in just collections that you've installed. And some people have, there's attached to different GitHub repositories. So you can see the ones that are linked in here. So that's one place I know of that where you could find that sort of thing. I can't remember if there's an online QGIS portal for that kind of stuff as well or not. That's a good question. So that would be a great challenge exercise, is to try to redo as much of this analysis as you could in the model builder.
Okay, can you use Google in the model builder?
Yeah, because you can, all those Google tools are in here. So if we look in here a little more closely, you can see the Google processing tools are in here. And so you can, and a lot of these are just those commands and have places where you can, all those GUI front ends to these command line tools have a place where you can input your own flags in those commands to make them do whatever you want. So raster conversion, if you go to Google Translate and add a Google Translate algorithm in here, you can look at the advanced parameters. This would be just like the tool that you would run in standard QGIS. So you can, for example, add additional raster creation option flags here. So in that way, yeah, you could use any of those Google commands in the model builder. You just have to format them in the GUI. And of course, if you had a Python script that basically just ran one of those Google commands, you could pull that in here too, as a, because all the script tools are also available in here. So, there's a lot of options there. That must be white box tools. But if you had any other third-party processing algorithms like white box tools, in here you can use those processing algorithms in the modeler as well. So there's a lot of pretty much anything you can do in QGIS, you can do in the modeler. There are some, these are the tools that are unique to the modeler that aren't in the normal QGIS processing toolbox. Things like adding a conditional branch in your model. If this, then do that. Creating directories, raise exceptions and messages or warnings when something happens, rename a layer. So there's some string concatenation. So there's some nice algorithms in here that you would only need to use in a modeling environment. And then you can even mark up these models. Where is that? You can, yeah, this from the edit menu, add group box. I can add these boxes, which are just for graphic reasons. But if you want to make a nice presentation and kind of break your model up into components visually so that you can show it to your supervisor or your customer what different parts of the model do, you can add these little group boxes and you can change their color and spell stuff. Add your own labels to them, and so you can do that as well. And then you can export the model also, not just as a Python script, but as an image to just show the workflow that you're using for whatever it is you're doing. So it's a very, very powerful environment that I think probably gets a little underused. Always takes a long time to put one of these together, but when you're going to be repeating the same workflow over and over and over again, even a simple model can help save time in your day-to-day work. Just to a model that does something, and whenever you have to do that, you can just run that model tool instead of having to produce all the steps from scratch.
Okay, I have another question. This was a really nice course, Kurt. And if I want to learn more, or we want to learn more, is there any place you can recommend online? I'm sure there are lots of free tutorials around there, but is there anything special you can recommend?
Well, yeah, there's my colleague Hans van der Kwast has OpenCourseWare.
And maybe also with regards to, didn't you write a few books about hydraulic and water?
Yes.
Yes, I'm also curious about that.
Here it is. No, that's not it. Yeah, here's the website, courses, GIS, opencourseware.org. So I'll paste this into the chat. There's a lot in here. And yeah, shameless plug. Go to Locate Press. There's a lot of great books in here. But Hans van der Kwast and I wrote QGIS for hydrological applications. It was just produced, the second edition, just a year ago. And so we're using PC Raster for all the hydrological components of that. So it's a really nice update to this book. And then, of course, Discover QGIS 3X. The analysis we just did in this course is actually a chapter in this book. There are, and it has like basically 32 different lab exercises or 32 short courses in it, everywhere from beginning with QGIS all the way up to data visualization. And at Septima, we also offer other courses. And so right now, we have some upcoming courses on continuing with QGIS and effective digitizing in QGIS. My colleague Mia teaches these, advanced QGIS analysis also. And then I have an upcoming class in June on data visualization with QGIS, where you learn how to do a lot of fancy data styling things. And then, yeah, so we have a whole suite of QGIS courses and PostgreSQL and MS SQL courses as well. So you can visit our courses page to see these. And then I guess the other thing I would mention is Ujjwal Gandhi, Spatial Thoughts. Go to spatialthoughts.com. He has a lot of open courseware too. Some of his classes are up on that open courseware page, but he does really great things.
Great, thanks.
He has some free courses and paid courses, so you can browse through his stuff too.
Nice, thank you.
You're welcome. Well, thanks everybody. It was a great class. You had lots of good questions. It makes it a lot more fun and interesting when people actually have questions. So I appreciate your participation in the course, and hope to see you at an upcoming QGIS meeting or something, or a future class.
Thank you very much. Very practical, nice course.
Great. And I'll send out this recording to you in a few minutes. So you have that. And cheers, everyone.
Great. See you.
Okay.
See you.
Bye.
Bye.